So now that we looked at the natural biological pump that does the ocean uptake, we talked about the solubility pump and the biological pump, BCP, biological carbon pump. Of course, solubility pump determines a lot of the CO2 uptake, even when biology is very strong, because the circulation contributes much more often than the biological pump, which is the photosynthesis, and then a lot of it gets recycled, respired back, and so on. So what makes to the ocean floor depends on both of these things. So if you know the natural processes, then can you enhance them and use them carefully to actually put more CO2 into the ocean? And of course, if we are acidifying the oceans and reducing the pH, then you basically want to find ways to put the pH back to its place by putting more CO2 into the ocean, but obviously you have to monitor the impacts, unintended consequences, and so on. So we'll look at several methods, discuss kind of a research news kind of article from Science on how alkalinity enhancement experiments are being done already, and so on. Okay, iron fertilization has been done already. I have discussed it elsewhere. Many places in the ocean, iron is a limiting nutrient, so even when upwelling brings a lot of nitrate, for example, the nitrate may remove unconsumed, unused, and those are called high nitrogen or high nitrate, low chlorophyll areas like the Eastern Pacific, the Southern Ocean, North Atlantic, and so on. So if you go there and dump some iron, you can enhance photosynthesis, but then you have to worry about whether that enhanced photosynthesis is actually increasing the export to the bottom of the ocean, or that's also getting recycled, or maybe having unintended consequences like using up a lot of oxygen to respire the enhanced photosynthesized carbohydrates, right? So all these are important considerations. So Ocean Visions is an organization that provided some very nice graphics that I'm going to steal and use with credit, of course. I think this is one of the organizations that's Manu Di Lorenzo is involved. He used to be at Georgia Tech with his superstar wife Kim Cobb. Both have moved to Brown University now. A brilliant team of scientists. So what are the various ocean-based carbon dioxide removal methods? Electrochemical ocean carbon dioxide removal, we already talked about. We will talk about alkalinity enhancements again. I've talked about it elsewhere. I'm just trying to put these together in one place, so it's okay to repeat some topics in different places. Deep sea storage, so this is more about how to take the captured CO2 and put it way down in the deep sea so that it stays there for a long time. The main purpose is to take it away or out of the atmosphere where it can cause energy balance and global warming, energy imbalance and global warming, and put it away for a long enough time. Geologic sequestration is thousands and millions of years, of course. Restoring living blue carbon, this is a very important natural method to do these things. We'll discuss a little bit. I've discussed already elsewhere about blue carbon enhancing subaquatic vegetation, which can, including mangroves, to enhance natural CO2 uptake, and they convert it to organic matter. They enhance oxygen, they provide habitats, they provide protection against storms, and lots of beautiful things happen. We have, of course, destroyed a lot of the coastal vegetation over the years across the planet. Microalgae cultivation, we'll look at an infographic on this. Macroalgae cultivation and carbon sequestration, we will talk about this. So macroalgae you can think of as seaweeds, kelp, and so on. Microalgae are, of course, photosynthesizing algae, small, tiny, cannot be seen with naked eye sometimes unless they cluster together or they're in a big bloom. Sorry, this is electrochemical, this is ocean alkalinity, so we'll see what the differences are. Basically, again, you're talking about taking ocean water in and releasing it back and producing some other usable water resource here. Water is always a valuable commodity, as you know. And there is, of course, the artificial upwelling and downwelling. methods that we'll look at. So I'll keep this short, each infographic as its own thing. This is only 5 minutes, but that's okay. Makes it easier to quickly listen to if you want, or you can listen to them all together. But usually the podcasts are 5 to 10 minutes, 15 minutes, but this one, all of these will be relatively short. Okay, so see you in the next topic, which is actually research news on ocean alkalinity experiments in the Halifax region by scientists and private companies, with funding from private companies and governments and so on. Okay, so see you.